Well, hello everyone. How are y'all doing? Yeah, I am here. So medicated, but I'm here. And Dr. Albers, so good to see you. Sorry, I was under the weather a little bit.
Not at all. I'm glad that you're back and that you're better.
Yeah, I felt like I was bound for the other side. I really thought there on Friday that the ticket was being cashed in.
Oh my goodness.
Well, so it's so good to see you, and so good to see everyone in the chat room. Thank you, everyone. So, Claudia, you and I were talking, as we are known to do.
Yeah.
And you wrote some pretty cool articles, and I have a good thing. Well, hello, everyone. Brian, how are you? Claudia, the room is filling up. I just want to say thank you to everyone that sent the get well energy. Wow, it works. Because I tell you, I was a grown man crying literally on Friday evening. It was pretty sad there. So Claudia, I wanted to show you something that a viewer sent in. And I know everyone is really going to dig this. So, do you know what those are?
It looks like chemtrail craft. I don't even call them planes anymore because I don't think they. Ooh.
Uh-huh.
It
Thought that might get your attention.
It looks like a military plane.
Oh, and it is indeed. I believe they call those the stealth bombers, but wait till you see.
Bombers, yes.
Now, our listener is just a fabulous person, and they have taken detailed records of these. As the person told me, there can be squadrons of them. And there you see it. Ladies and gentlemen, I mean, there you see it, Dr. Albers. That is a B-2 bomber.
Absolutely.
And look at this chemtrail that this thing throws off.
No wonder they move so fast. I've been, wondering how they can move so fast. So obviously they're using these high-tech planes.
They are. And Claudia, I wanted you to pay attention to this. I don't even know the person caught this, but that is something right there. When I saw that, I went, well.
There's definitely something there. It definitely looks round and dark.
Yes, it looks.
Yeah, there's a lot of stuff up there. I've been thinking for a while that they have a lot of devices, but they probably have a lot more than I even think.
So check this one out. The person told me they can get, sometimes there they are again.
Oh my goodness, you don't see any plane at all there.
Look at that. These are quite remarkable captures, and this person has documented. They want to remain anonymous. These are 3 stealth bombers right here. And I'll pull it up so everyone can see. Now,
they obviously have cloaking capability.
Exactly. This person has documented this, that there's just nothing out there.
Right.
And so it gets better. Here's one that these are incredibly fast objects.
Yes.
Look at that.
Wow, you can just faintly see it.
Yeah.
It looks like a triangle, so that's not a normal plane. Yeah.
It gets better. So this person lives apparently in the flight path of this Look at this.
Yeah, that's definitely not a normal plane.
No, I got the same feeling. I went, this is just fabulous capture of.
And what is that to the right?
I don't know. I've been looking. You're looking at this thing right here? Yeah. I don't know if that was the moon, but if it was into relationship.
No, Don't think that's the moon.
I don't think it is either. There it is, folks.
Oh, it's a little rainbow. It's probably refraction related, so some kind of lens effect.
But what's so weird, I don't know where it comes from.
Yeah, well, they have all these lenses.
Now here it's different.
So
oh, wait a minute.
You get these little effects. They basically hiding the outside of the atmosphere with all these lenses, these cloaking devices.
Well, you know what I thought? I thought simulator when I looked at that, but
well, you know, it's all part of it because they cannot operate simulators without lenses. Wherever you see these lens effects, these rainbows, it's because they're simulating the sky, the light sources. Wow.
there you go,
That
folks.
is unmistakable.
So we know where the exhaust is coming out.
Mm-hmm.
Now, what I don't understand about this, I did a little reading on this B-2 stealth bomber. Number one, the fuel, it's not supposed to put a contrail out.
Yeah, I'm sure.
So someone I was talking to in the field showed me this. This is a port on this engine. So we're seeing, you know, I don't think the government realizes that we're capturing this on them. But there you go, Claudia.
Yeah, it's unmistakable, unbelievable evidence, Wayne, that they're using these high-tech planes, military planes. They're not using normal planes anymore. But I've been thinking that for a while, and I've been thinking they have cloaking capabilities.
Yeah, well.
Unmistakable. You can see B-52, the Delta Wing.
Look at that. This was the first I've ever seen of, you know, such detailed pictures of.
You know, and what is strange, do you see that the chemtrail does not start until some distance from the plane?
Yes.
It doesn't mean that it's not, a contrail is supposed to, but a chemtrail seems to be different.
It does.
Yeah, because it's the condensation that's occurring and it's only starting a distance from the plane.
And so I have, look at this.
Wow.
I mean.
They're flying in formation.
Yep.
Amazing.
And then I wanted to show the people the difference because here's military again, but these are the typical ones that I see.
Yeah, I think they may be using a holographic projection to make them look like this, because I've seen some, plus they move too fast to be ordinary planes.
Yes.
So I think they may be using craft that have cloaking capabilities and holographic. So they can project another image. I mean, they doing this with just about everything. The moon simulators and even the sun simulators would have to have some kind of projection on it, some kind of holographic projection or just a plain project, so that anybody pointing a telescope at it with a solar filter will see whatever features are supposed to be on the sun, like any sunspots.
So before, you know, I had these I was going to show us last week. That didn't happen. So let me share this with you, Claudia. Mm-hmm. So this was taken over my house. I guess X marks the spot. But what was so bizarre was that the cameras I have don't give off these type of discolorizations on the camera. And this effect was, this was about 8 days ago, Claudia.
Oh my goodness.
Look at what the sun was doing and look what I caught here. And I want to show everyone this. because I couldn't figure out wherever this bird is. I don't know, and I can't figure out how it's getting the shadow ahead of it when the sun. Look at that.
Yeah, I've actually seen chemtrails making shadows on clouds above them. And there's only one way that's possible. They're actually shining light from below upwards.
Oh, hadn't thought about that. Look at the.
They actually have light sources that are shining upwards to create more glare, so we don't see what's out there.
Well, I just thought that was a pretty bizarre picture.
It is bizarre. I think our skies are getting more and more bizarre by the day.
I was going to say that. It seems like they really are. Now, you was telling me that Scott had found some pretty interesting things over on his channel, right?
Yes, he did a video about where you can see two suns, and it's from 2015, and these pictures were taken from an airport, and it was seen by everybody at the airport. You know, even the tower people were taking pictures of this. There were two suns side by side in the sky, one brighter, one darker orange. So obviously one was the sun, and this was years ago, and the other one, but they were about the same size.
You know, I've come to the conclusion of this. Reading this book, you and I were talking about the flare star. And I didn't realize that every minute our planet is being hit by what they call mini comets. They're very tiny, but they're hitting us at a rate of 200 a minute. And that I did not realize this, that they've actually photographed this, that they're actually punching holes through our ionosphere.
Very interesting.
So you have...
Yes. Now, the question is, Wayne, if that's occurring, what is happening to the ISS?
What is happening to the ISS? Because if that is holding true, those folks would be Swiss cheese up there. And probably on a quantum level as well.
Mm-hmm.
So you wrote some papers. I found this one to be absolutely fascinating because it goes with what I'm studying right now. Mm-hmm. So tell us what we have here.
Okay, so Nico is this small, it's called a minor planet. It's a trans-Newtonian object because it's found, it's semi-major X, so its average distance from the sun is greater than Neptune's orbit. Neptune's orbit is 30 AU, and 1 AU is the distance between the Earth and the sun. So it's 30 times its average distance, just for Neptune, it's 30 times the distance between the Earth and the sun. But this... So
that would be what, about 3.4 billion miles?
Yeah, well, it's 150, well, it's 93
billion from here.
Billion. So 30 times that. Yeah,
that is about right. Okay.
Yeah.
Okay.
All right. So this Nico is very strange because, first of all, it is very far and it's small. Its diameter is only about 200 kilometers. It's on a very elliptical orbit, which I show there what the elliptical orbit looks like. I show the sun at one of the foci, and then Nico would move in that orbit. And the closest distance is 23.9 AU to the sun, and the furthest distance is 47.5. So it actually comes in closer to the sun than Neptune does. So it's quite an elliptical orbit.
That is.
Yeah. But the strangest thing is that it's nearly in a polar orbit. Its orbital inclination is 80 degrees.
Okay.
So see, I illustrated that there with that diagram, which is very strange. because all objects in the solar system orbit the sun in an orbit which is close to the ecliptic plane, and the ecliptic plane is defined by the Earth's orbit, as you know.
Correct.
But this object orbits it's nearly polar, that is, it nearly goes over the sun's north pole. And it's not the only one. There are two now that have been discovered. This one was discovered in 2016, and another one was discovered a few years before that. The other one has if we scroll down, it's got a short name, Drac, and it's in a very similar orbit. It's even more elliptical than Nikus. And it's at an orbital inclination of 77. That's the other one. So it's very, now we do not expect objects that have, at least I don't, with what I've discovered about the solar system. And what I have used is James McKenny's observations of comets, where he shows that comets actually become captured planets. And every time they come in through the solar system, the orbit becomes more and more circular. So the moment you have an object that is in a very elliptical orbit, that suggests that it's a new capture for the solar system. It hasn't been for a long time. And you see, this is the other one. It's the 2008 KV42. So its orbit is even more elliptical than Nikus. And it's also at an inclination, it's almost the same as Nikus. It's at 77 degrees, so that's only 3 degrees short of the 80 degrees. So these two objects seem very similar. It's a bit smaller than Nikus. I think its diameter is only about 90, between 50 and 90 kilometers. So you can see I illustrated its orbit there. It's even more elliptical.
And
polar.
So we're coming in for this. So there would have to be another influence that would send an object in the counter-ecliptical plane, which would be, as you said, more north-south.
Yeah, what happens is it depends on where it comes from.
Okay.
It probably came from either the very far ecliptic or the very north ecliptic. And then when it starts orbiting the sun, it will start orbiting in according to the direction it came from. And then as it starts interacting with the solar system, which is in the form of a capacitor, because the sun sends out ions in the solar wind, and they form nebula clouds or rings around the sun.
Okay.
And comets, as they come in, they pull material from these clouds, and that material then fills the tail of the comet. So that's how we know what's in the clouds, by how the material in the comet's tail changes. And that's where James McKenny came in, because I read his book, or Planet X, Comets and Earth Changes. And he was at a university many years ago when these observations were first being made. So he made the connection, whilst other astronomers refused to, because they knew they would lose their job if they started talking about electric fields, and start saying that comets are not a snowy snowballs.
Snowballs, yeah.
Snowballs. But he refused to go along with that, and he made the right connections, and he wrote his book. Of course, he lost his job because of it.
Like we've never heard that before.
Yes, because, they don't want people to know anything about what's actually happening. But he discovered that that's what the solar system is like. It's an electrical system. It's like a capacitor. It's got rings, just like Saturn has rings. It's also due to being an electrical star. And so the sun has rings, and the furthest ring goes out as far as Pluto's orbit, or a bit beyond that, starts about where Jupiter is. And that's where the lightest ions are, which are from hydrogen to sulfur. So that includes helium. People have been asking me about where the helium goes. That's where it goes. the furthest ring, because the lighted nuclei are propelled by the solar wind further, so they end up in the furthest ring. And I show there the sun is in the middle. The inner capacitor plate is the sun's corona, which is mainly electrons, so it's negatively charged. And then there are rings around it, several different rings. You find different materials in each ring, different ions. They're all positive ions. And then as the comet comes in, it draws material from the nearest ring, and it draws material from the corona. And then they meet at the comet nucleus and they interact. And when they interact, you get this ionization and atoms going down to the ground state through absorbing electrons. And then you get the coma, and it emits light, all because of this. And then the interaction goes right into the tail, and that's why the tail emits light as well. And you also get, once the hydrogen and oxygen, for example, gain electrons and become neutral, then they can have a chemical reaction and form water. And that's why we get water in the tail of comets. Not because there's ice in them, they're not. They're just like asteroids, they're rocky. But the water forms due to these chemical reactions.
Claudia, two things. Number one, so the sun that we're getting right now, the energy from it, was generated from the core of the sun 173,000 years ago, right?
Well, we don't actually know when. As far, I've written another article where, again, following from what James McKenney has found in Holton Hart, what happens where stars are formed is actually at the galactic nucleus. So all stars seem to form at the galactic nucleus, although some star systems may fission into two stars, but the main star will start at the nucleus and be propelled outwards. Just like the CMEs are propelled outwards from stars, the galactic nucleus does the same thing, but at a larger scale. So material is hurled out from the galactic nucleus. It condenses into it splits into particles first. The light that it emits splits into particles. Fusion occurs, all elements are created, and then it condenses into dense cores, and lighter material around it. The larger ones will become stars, the smaller ones will become planets, but they're very similar.
No, what I was saying was that the light we're getting from the sun, it started at our sun's core, which is actually, this is a pretty good drawing, that, 400,000 miles
okay, yes, it's 93 million miles from Earth, yes. And it takes 8 minutes to reach Earth, that light.
No, because what I was saying, if we took our star, its center, and whatever generating force that is, must be amazing. But the surface, to get to the surface of the sun, is 173,000 year journey.
Oh yes, no. That's not what's occurring. Well, they want you to believe that's what's occurring, but it cannot be. Because first of all, we know the sun goes dark.
Okay.
I mean, that's unquestionable. I know NASA tries to protect that with everything they have, but the fact that during the STO eclipse season, as the darkness progresses across the sun, the corona shrinks back, tells me that the sun definitely goes dark.
Okay, I agree with that as well.
Okay, so now, because the surface of the sun goes dark, I mean, the whole sun goes dark, we cannot have energy and light coming from the center all the time. If that was occurring, that would be impossible.
Right.
So there are two things that are impossible. We cannot have thermonuclear reactions from the core. I believe it's actually the opposite. What we're having is decay of unstable nuclei. So it's fission that's driving stars, and in fact planets as well, because that's what's occurring in the interior of Earth too, to produce heat.
Okay, I agree.
Energy. It's fission. So it's the same thing as we have powering nuclear power plants. That's what's powering the sun and the planets from the core. And so the other thing that's not occurring is that we are told that stars emit radiation because of the temperature of their surfaces. That cannot be it either, because temperature cannot dissipate instantaneously and cause a star to go dark. That's impossible. So what is actually happening is the gravitational energy that the star generates goes into generating an electric potential difference between the core and the outer layer. And then what we have is just a potential difference between a positive and a negative. And that causes lightning, electric discharges. You know, like we have lightning on Earth. And it's the same thing. In fact, the lightning we have in Earth's atmosphere and the lightning we have in the atmosphere of the sun is exactly the same, except in the sun is so intense that it looks like a continuous discharge. And
so go ahead. I'm sorry.
It's okay if you want to ask a question.
Yeah, I was thinking that our star, our solar system, in the quadrant of space that we're in a cloud right now. We're in a cosmic cloud, and that's what I'm reading. Do you accept that as, because that would also cause a lot of electrical reaction with more denser material, right?
The thing is, first of all, we have to realize that the sun itself generates its own cloud rings. There we are. This is the inner ring. It's called the zodiacal ring. And apparently all stars produce this. You know that Saturn produces rings because it's a star. But they're small because it's not a very powerful star. Bigger stars, more powerful stars, produce much larger ring patterns than Saturn does.
And they come in all shapes and sizes, right? Stars. Yeah, I mean, there's some that failed and some that never launched.
It depends on how much energy they generate in the core, which then goes into what kind of electric potential they're able to produce and how much light they're able to then generate in the atmosphere. It's the same thing with planets. Saturn, if you look into it, they talk about the huge storms on Saturn. What they're talking about is the lightning that occurs in its atmosphere. That's where all the radiation's coming from. Earth generates lightning as well because it also produces a potential difference between the surface and the top of the ionosphere. And then there's lightning. And what happens when we have lightning? We have light emission and the air becomes hotter around where the lightning's occurring. That's where the temperature's coming from. That's where the light's coming from. It's all coming from these electric discharges.
And this is a cloud, right? I mean,
that's a cloud. That's a toroidal cloud around a star. And as you move further out, so that will be the inner cloud, the inner ring for a star. And then there will be a gap, and then there will be another one, and another one, and another one.
And would you concur that our solar system, as we're moving through space, could actually move through, I don't know what you would call them.
You see, all the stars in a galaxy are producing these clouds. So what happens? The galactic arms are filled with clouds because the stars are emitting all this material from their surfaces. They're having CMEs, they're having solar wind. The galactic nucleus itself is also ejecting material outwards.
I read an article, Claudia, I had time to read, that our sun, they estimate, takes 50 million years to go from one spiral to the next outer spiral. Does that sound feasible?
Yeah. What actually happens is the spirals are formed by the stars having an elliptical orbit with the perihelion, the closest position. I don't think I have it in this article. It's in that I wrote. It's the one that starts dark matter, where I explain this.
Okay. I'll need to find it.
And it's what it's thanks to James McCann. He explains this in his book, and he draws the orbit. So the stars are formed right close to the galactic nucleus, and they eject it out and they form an elliptical orbit. But at the aphelion position, at the furthest position from the center of the galaxy, they usually die.
Oh, okay.
The light goes out, and then they return. They go back to the galactic nucleus, but they're not emitting light, so we don't see them. And that's why the galactic arms seem to end out there in space.
Okay.
And there's all this extra matter that does not emit light because the stars, and that's what these stellar cores really are. They did stars that were not emitting light. I think they were on their way back to the galactic nucleus, and they somehow found the sun and were attracted to it. But the galactic nucleus will absorb them. It's strong enough to absorb them. The sun does not seem strong enough to do that.
Could we talk about the dark star? The theory on that is that if we have stars, like red giants, we have, yellow dwarfs. I think ours is a white dwarf, right?
Mm-hmm.
Technically, I think it's where we're classified.
It's a G5, yeah. Nowadays, I'm not sure if they call it a white dwarf or a yellow dwarf. They've changed the name.
Of course they are. But I can't do that. I'll start coughing and I won't stop.
The dark star is what Tarot calls basically this star that's coming in, but it's basically the same as Nemesis. A lot of people call it Nemesis. It's basically supposed to be the sun's twin.
Yes.
And as you know, in the universe, most star systems are binary. I think 80% of stars are in a binary star system. So it's very likely that the sun has a twin, but we do not see it, except as Scott showed in his video now and then. And so I wrote an article about it because obviously there does seem to be a star that has come into the solar system, or it's very close to being inside the solar system, and it's affecting our planet because, Tarot has tracked it through the earthquakes and so on. So, I think data is evidence that we do have another star. This star is not a stellar core. It's not a dead star. The reason why I know it's not a dead star, because it's interacting gravitationally like normal objects. In other words, we can feel a strong gravitational influence from it from very far away. So it's not dead. It's just not emitting light. But we see what's happening with the sun. Our sun is losing its ability to emit light. It's still holding on to all its planets. It's gravitationally sound. It's still, because it's still generating gravitational energy in the core. That energy will probably last a couple more million years.
And, I don't find this to be so far-fetched. I tend to believe that we're Earth, our star, they don't know where it originated from. As you were saying, they all originate from a nursery out there. We know that, but what quadrant of space? And I keep reading that we were part of a Sagittarius dwarf elliptical galaxy, that we're part of this collision that started 100 million years ago.
Well, that's definitely a possibility. Whether we started from, if stars are being incorporated from the Sagittarius dwarf galaxy into this galaxy, it's definitely a possibility that we did not originate with the Milky Way galaxy galactic nucleus, but with the Sagittarius dwarf galaxy galactic nucleus. It doesn't matter which one we originated from. We originated in one.
Well, yeah, I agree with you. And so I keep on thinking every time now, all right, you're talking about galaxies colliding. That's a lot of mass. That's a lot of matter. That's a lot of energy that's being expended.
Yeah, there would be a lot of energy, but most of the energy comes from the galactic nucleus.
Okay.
Because it's like a star. It's like a huge star with a huge amount of energy, and it's generating all the stars we see in the galactic arms.
So
they all spewed out from it, just like the sun spews out all this material, the solar wind, the CMEs, and fills its rings. The galactic nucleus is doing the same thing, but on a larger scale, but it's the same thing.
So Claudia, when we talk about these collisions, then I could see where stars would collide. I would see that there would be fragments from those stellar explosions. What I now translate as stellar cores, we're just understanding them.
Yeah, I mean, there's definitely a possibility. We seem to have stars that die. They lose their belt. There's a stellar core in the sun's corona. We know they are there. They absorb energy from the sun. You can see the connection it's making there with the sun. It's drawing matter from the sun. But they interact very weakly through the gravitational interaction with the sun. The force they exert on the sun is a tidal, which is due to a differential gravitational interaction. In other words, it's strong right below where the object is, but it's weak further.
Well, you can actually see it. Look in that. Claudia, which is more influential? Is it electromagnetic or gravity?
Well, the electromagnetic interaction, when we compare it to the standard gravitational interaction that, the accepted model, the electromagnetic is much stronger.
Okay.
But what I have discovered is that one does not occur without the other. And the forces that we have in the universe is that the electric causes light to split and the gravitational interaction to start occurring through the particles that emerge, that have mass. And mass is associated with gravity. So light, it's actually the electric force, the electromagnetic interaction, that causes light to split, particles of mass to emerge, and the gravitational interaction then to occur. But the gravitational interaction has a part that separates charges, positive on one side, negative on the other. And the moment you separate particles with charge, you have an electromagnetic interaction occurring. So there's a feedback loop between the two.
Amazing. We're still learning so much about our star, our sun. I mean,
yeah. The thing is, the stellar cores, through observing the stellar cores, I've been able to realize what is happening, and that the universe is all made out of light. Everything seems to come out of light. Matter comes out of light. The interactions, the electromagnetic and the gravitational and the magnetic all come out of light itself. It's absolutely amazing. So what I explain here is that Nico and the other one, the 2008 KV42, are new captures. And what they show is that our solar system is dynamic. It was not created a long time ago, because the accepted theory is that a cloud of gas collapsed into a star, and then whatever was left formed the planets through matter accretion. But what I'm saying is that what James McKenney also says is that the planetary systems, probably some parts of it will form right at the beginning. The sun forms, the planets all there, they all captured, they start rotating around the bigger object, which is the sun, which occurs at the galactic nucleus. They are hurled outwards, and then throughout the lifetime of that planetary system, more planets or stars or gas giants are captured.
We live in an amazing universe, Claudia.
Yeah. And these are the newest captures. Nico is one of the newest captures, and it shows that we're living in a dynamic solar system, dynamic universe. It's changing all the time.
And I can remember, because I am, a little older, that in my astronomy classes, we never heard of Sirius. We never heard of Ceres, never heard of anything coming in. And I'm so glad we're doing this. So, Claudia, I'm going to stop share here because I want to pull up something and get your feedback on this. That what we have found, and I'm going to pull this up real quick. So, okay, I got that going. I think you might like this, Claudia. I found this graphic. And so, and by the way, we did not talk before we came on air. So as you were talking about, this is a, what we think Jupiter was going to be as a sun, as a star.
Yeah.
And that it failed. But its influence is capturing, what is it now? Is it 70?
Yeah, something like that. The last I heard was 69. It may be 70 by now. It keeps capturing more. And that's not surprising because when we have all these stellar cores coming in, it's very likely that it will capture some. And or it may even capture other objects, comets that are on their way to becoming planets. Because that's what happens with comets. They absorb material and eventually they turn into planets. But Jupiter is actually a star because it emits radiation. It has a lot of lightning occurring in its atmosphere, and it also produces a ring around it. And that's the test as well. We know it produces a ring because there was a comet. It was Schumacher-Levy that impacted Jupiter. And it had a certain material, I think it had water in its tail. And the moment it crossed over into a region close to Jupiter, what was in its tail changed from water to sulfur dioxide. So that shows that Jupiter was creating its own nebula cloud, its own ring pattern. And that's the test. It's a star.
Yes. And I remember when Schumacher-Levy, I still remember Goddard, and I remember the director as those pictures were coming in. I couldn't believe the destructive damage that Jupiter had incurred. And had it been Earth, it'd annihilate us. It would have been a life-ending event, extinction event.
Because it was an electrical interaction. And we were not dealing with an object that was mainly made out of ice. We were dealing with a rock that was highly charged because it had already entered the solar system and it had already charged up in the solar capacitor. It was a highly charged object. So when it came close to Jupiter, it interacts with Jupiter's negative outer layer and it discharges. We get a huge interaction. That's what occurred. And that's why Schumacher was killed, I believe, because he decided, oh my goodness, what is going on? But the powers that be didn't want people to know that we're having these electrical interactions in the universe and that comets are so powerful and so dangerous.
So can I ask a layman's question here? Every time I look at the asteroid belt, I cannot help but not think, number one, that there was probably a planet there, but now wouldn't this, and I'm thinking electrical, Claudia, wouldn't this, with all the interaction and everything else, actually have an electrical current itself around the interstellar planets? Yeah.
There are asteroids. I've written some articles about it. There's one or two that now and then develops a tail. And they are asteroids from the asteroid belt. And they do so because their orbits are elliptical. So in a round orbit, in a circular orbit, we don't get this discharging because basically the planet or the asteroid is charged to a certain potential, and that does not change. So we don't see the electrical effects. But the moment it has an elliptical orbit, that's why comets charge up so much, because they come in at an incredible elliptical orbit. So they go through a lot of potential changes as they move in that very elliptical orbit. So they charge immensely in the solar capacitor. But the planets that have circular orbits do not. Well, they have to be perfectly circular. They still charge somewhat. That's what the ion tail, they call it the magnetosphere, the magnetotail of planets, is actually due to the planets charging by moving in the solar capacitor.
So you said something earlier that was interesting, was on the perception of how long it takes for stars to form, etc. That we have, I would say the public at large has this perception that it's billions of years, that this is something that happened so far long ago. But every time I look at this, Claudia, I just get this sense that there was something that happened, and I got this sense that it wasn't that long ago.
Yes, that's true, because we know that Mars lost its oceans not so long ago. And the way we know that is because the river beds are still very well defined. And we know that Mars has these dust storms, and the dust storms would erode the pattern of the riverbeds, but they're not that eroded. So whatever happened that got Mars to lose its oceans and its rivers was not that long ago, perhaps about 4,000 years ago. And this I believe is due to a comet that was close to becoming a planet, came in, and Mars is further out. So it most likely encountered Mars first. It went past Mars, very close to Mars. And if the comet was just larger than Mars, it would suck up through the gravitational interaction whatever it could. So it would be the liquids, most of its atmosphere, but that's probably why Mars has such a thin atmosphere. So it lost most of its atmosphere, lost its oceans. And the comet, because it was larger than Mars, pulled it all up. And this is actually James McCanney's ideas, that he came up with it. And then the comet came in closer towards the sun, or went around the sun and then came back and encountered Earth. By then it had so much water because it pulled all of Mars' oceans. So when it went past the Earth, and because it must have been smaller than Earth, instead of it pulling Earth's oceans out, it must have instead pulled, actually dropped, the Earth pulled the water off it, and that would have caused a huge flood.
Well, every time I see this, like I said, I just don't think we're getting the full story. This just reminds me, Claudia, that, when I look at all the Trojan asteroids that surround Jupiter, and then here, I mean, I keep on thinking that if this was recent, I don't think it's over.
Yeah, I don't think so. We have the stellar cores. We know they are here. I think they keep coming in. The sun keeps getting weaker. We have all these new objects coming in. We seem to have a star that is reaching perihelion, or has reached perihelion, that may be the sun's twin. And that star we often call Nemesis. I think there is evidence that the star is here. It's not a dead star, but it seems not to be emitting light most of the time. It may emit light now and then we would see two of them. We may see two of them, maybe.
Would an outside gravitational force cause a planet to tilt off its axis, say, let's say for Earth, normal 23.5 degrees, that if we saw a 70-degree tilt, which we see Neptune right now seems to be encountering something, it's flipped on its side again.
Oh my goodness.
Check it out.
Oh, well, definitely. That's the thing. We would need an object that passes very close. And the moment that happens, you get a sudden change. What actually happens is a crustal displacement because the core is locked onto the sun, the core of the planet, the rocky part. So the Earth's core doesn't change and it keeps on rotating. But when a comet or some other object passes very close, it causes a tidal wave inside the liquid part of the planet. And that tidal wave, it is very fast moving, and it causes the top of the crust, the mantle and the crust, to be displaced with it as the tidal wave moves, and it disconnects from the core. So it turns.
I was trying to get a... Go ahead, I'm sorry.
Yeah, the core stays in the same position. It's locked to the sun, and the crust rotates about it. And that's why then the poles seem to be in a different place, because the position of the poles is a combination of where the magnetic poles are for the core and for the outer part. The same thing would happen with a gas giant. I think all planets, all stars have a very dense, solid cores. I
agree. And I wanted to show this. This is, was it a Oumuamua? Is that, I believe, how they're saying that came through? I just saw a program on this, and what we're learning about this is going to change. It's going to have to change, I think, our perception on physics, astrophysics particularly, because this object here defies what we have thought as formation of solar system. This one is...
Yeah, it came from the very north ecliptic.
Yeah, not of our, as they're saying, not from our neighborhood.
No, definitely not. The thing is, if you look at it, it doesn't even look like a normal object. Actually, it looks like a spaceship to me.
That seems to be, as I think some of the great minds, such as yourself, have said, if you're going to do interstellar travel, this is what you'd want.
Exactly. You would cloak your ship in something like this, or surrounded by something that looks almost natural. But the shape, it doesn't even look natural. Look at it.
And this is what, now this picture did not have this, but this area here, Claudia, is red.
It's red?
It's red. And so that just kind of this, well, what happened here? I don't know. Well,
we live in a very strange universe.
Yes, we are. Yes, we are. So I think someone said, what's the shirt say? The shirt says, be nice. So there you have it, folks. That's science, Claudia. That's science telling people to be nice. It's in the periodic table.
That's right. You just have to arrange it in just the right arrangement. And
see, so science could teach us how to be nice.
Yes, definitely. Look, it works to be nice, because when we're nice, other people tend to be nice as well.
I think you could write a paper on this, when you think about it. What would these elements have and how it would interact? See, this is why I enjoy doing this. Now, I'll probably go and crash after I get finished this, but I learned so much from this, Claudia, and I think the people do. So Brian is saying Oumuamua. Is that how they say that? Oumuamua? I don't know.
Oh, yes.
I'm just trying to, another one saying, and the giant mothership. Well, I think what Oumuamua means is scout, right?
Scout ship.
Yep. I believe in the Hawaiian tongue that's what it means is scout. So,
Okay.
and I still get this gut feeling as I'm reading now, because more and more astrophysicists, more physicists in general are saying, wait a minute. Let's kind of step back here, because maybe it's like you said, maybe we've gotten these perceptions of what we think the universe is expanding out and et cetera, that maybe some of our timelines are a little bit off. And if it's condensed to a much shorter time period, Claudia, that means we could have sudden change almost overnight, right?
Yes. In fact, don't forget what is happening in Kenya. Overnight, these huge fissures open up that the geologists said should take millions of years to occur. So it suddenly happened.
What's your thought on the Hawaiian Islands, by the way?
Yeah. Okay. So what I thought about that, what to me was the most critical was that 6.9 magnitude earthquake, because volcanic eruptions usually release pressure. That's what I've known
they're supposed to do.
So the eruption had already started, and suddenly you get a large earthquake like that. To me, told me there's something more here. This is something huge that's occurring, because the eruption itself did not release the pressure. And then we have this earthquake. And the earthquake meant that something major shifted underground. And obviously then the level of the volcano started dropping, which shows that the lava is moving it through, probably moved down into a new area. New fissures opened up, it moved into there. And that means that it could go offshore, it could open up somewhere else. And
okay, because that was a deep quake, if I was right.
Yeah.
And someone can check me out on this, but I believe that it was like 230 kilometers.
I'm not actually sure. I'm not sure how far it was.
We can look at that, but I know that it was significant, and I agree with you. So I heard today that now geologists are now, just what you just said right there was that maybe this could have a connection all the way to the West Coast.
Well, to tell you the truth, all magma will connect at the center of the Earth. Okay. But then there are channels that are cut, that the magma seems to have cut, because the whole surface of the Earth is broken up in fault zones that seem to connect in some way. And the magma finds ways, cuts channels through these weaker regions. So they are likely to all connect to the West Coast. There are many, many volcanoes along the West Coast of the United States. And it's likely that these are all connected in some way. Well, they are connected in the below the mantle, of course.
Yes.
But even higher up, there are often many connections. Now, the thing which is most dangerous about Hawaii is we may get a sudden eruption and a shift that may cause a tsunami. And that tsunami may affect all coastlines around the Pacific.
And we have evidence of that, because you can go right there in Oregon, in southern Washington, evidences of a tsunami coming in, and I believe, if I'm correct, 10 miles or so going inward, 1,000 feet tall.
Yeah.
Holy crap. That's a bad day.
Yeah, if it comes from Hawaii, it is quite far off the coast, California and so on. So it should decrease in size somewhat before it gets there. But
hey, before we leave, Earth, does it stay at a steady circumference, or is it like a ball that can shrink and expand?
The Earth should be able to shrink and expand because the size of a planet, and I actually looked at Earth, Earth seems to have expanded.
Thank you. Thank you.
And that is due to gravitational energy, because the stellar cores, you see how large some of them are. But the thing is, as they lose gravitational energy, the forces in the core that keeps it together decrease in strength. So it will expand, it will get larger. So if the Earth was able to generate more gravitational energy in the past, it may have been smaller. And then as the amount of gravitational energy decreased that it's able to generate, then the force keeping it together, it's actually gravitational, or the strong force, would decrease, and then it would expand. And the Earth seems to have expanded. I think there's plenty of evidence that all the continents fit together precisely on a much smaller Earth.
Yeah, you could have what, Gondwana and then Laurasia?
Yes.
So to me, we have the Kuiper Belt, right?
Mm-hmm.
We know that there are very large objects out in the Kuiper Belt. And I keep on thinking that if we have an object out there that is generating an electromagnetic field strong enough, it would have an influence. If it's having an influence on the outer planets, why would Earth be exempt?
Yeah, in fact, the evidence I have found is that Earth has captured at least one stellar core, possibly more. And these stellar cores are in orbit. They probably spiral inwards as they gain gravitational energy by drawing matter from the Earth itself. The gravitational attraction becomes stronger. They will spiral inwards. And then eventually they will be able to do what they do with the sun, and that is come in, make a connection, start drawing matter from the atmosphere and oceans. And when they do that, they become like a part of the planet. They rotate with the planet.
Okay.
And then they will disconnect and move back towards an orbit further out, probably. And eventually they'll start emitting light. And I think we have evidence that the Earth's atmosphere is being illuminated by objects. And now I used to think they were all around the sun. Now I think they may actually be around the Earth. I'm writing an article right now that looks a bit into that. And it's, I should, it's nearly finished, so I should make a video on it soon.
Will do.
And it talks about, it's actually called crepuscular rays, because they use the term crepuscular rays to say, oh, these divergent light beams in the atmosphere, they're normal, don't ask any questions. It's fine, it's all defined by this term. In fact, the term means just divergent rays. It's a descriptive term. There's no mechanism or explanation behind the phenomenon in it. So I wrote an article, and with diagrams, I explained what it means, and it should be easy to understand to everybody. Why do we have these divergent rays? Where do they come from? But it comes down to two things. We have artificial light sources in the atmosphere, and we have possibly stellar cores that are just outside the atmosphere that would also produce some of these divergent rays or divergent light beams.
I love this.
Yeah.
Well, that's why we have Monday nights.
Yes.
Because we're going to do that. Well, Dr. Albers, this has been a pleasure. My medication is starting to wear off. So before I start embarrassing myself, I just want to say thank you, everyone. We had a full group in here, 280 people or so. So, hey, I think I see Scott here.
Oh, easy.
Yeah. And he says my head was spinning. Yeah, try with a little medication. No, this is good. This is good. Well, again, another great class. I appreciate it, Dr. Albers. I really do.
Well, thank you for having me. It's fun for me to be able to talk about all these theories that I've come up with based on observation.
Yeah, yeah.
And, it helps me actually to.
Well, it helps me because when I go out and talk to other people, they go, man, where'd you learn that at?
That's good.
Because I have very smart people. Yeah, I'm going to get better, folks. So, all right. So I'll see you next Monday night.
Mm-hmm.
And everyone, thank you for coming in. I'll be much better next Monday. So, thank you. Thank you for all the energy. And we will see you all next week. All right, everyone, be good.